Cool. So this is actually a vulnerability that was inside Microsoft code. Are people familiar with C code? Yeah, we have some C programmers here. Does anybody see the bug here? It is a published bug. Basically, the bug is right here. They read in something that the attacker supplies, and then they change the type of that data to whatever the attacker wants. So basically, I can say that a string is a number is a string, and basically it'll treat it like it is. And this type of vulnerability is awesome to find because it was super easy to exploit. Basically what we did with this one was we gave them a string and said, hey, this is a C++ object. And basically it would just take the addresses we gave it, load it into memory at known offsets, and just execute code. Now, this vulnerability is sort of easy to miss because right here, the change type, the type of the variable in C++ is sort of obfuscated. But when you look at the compiler and the compiled code, it's actually a lot easier to read. Excuse me? Oh, so this was a vulnerability. Is anybody familiar with Microsoft ATL? Anybody code with that? Basically, whenever you write an ActiveX application, you generally use the Microsoft ATL or decide to write it on your own if you're really brave. But this was in code that affected almost every known ActiveX control inside the web browsers. So basically, just by using the Microsoft compiler, companies compiled this code in. And the interesting thing is, when you compiled this code in, it wasn't just a DLL that you could change on your system. Basically, this code compiled directly into the binary. And because of that, they had to go through and patch every single binary and update all of the third-party vendors with the new code before the public knew about it. I'm glad I didn't have to do that or take the rap for it. So here's another sort of type issue. Does anybody see the vulnerability in this one? It's one character. Okay, so the vulnerability is right here, that ampersand. Basically, instead of reading into an array, it read into the thing that points to the array. And because of that, it led to some very interesting vulnerabilities. I kind of show it up there, but you might not necessarily be familiar with how it'll compile. Basically, it allows you to read as much data as you want of whatever type directly onto the stack, overwriting whatever you want on the stack. This was a nice vulnerability, and again, this one was in the ATL, but it was in a certain part of Microsoft's ATL where they didn't distribute the code to the public. And because of that, most of the public was not vulnerable to this. However, most of Microsoft was. So this was a really big patch item and caused generally a lot of problems for them and resulted in the 7 or so releases since this vulnerability has been disclosed to the public. So that last one is kind of a readability issue. I don't know about you guys, but I have a problem catching a single ampersand inside C code when I've been reading through it for hours and hours on end. But I mentioned before that when you're looking at the binary, it's a lot easier to read. Who reads x86 code? So we do have a decent population here, right? So basically that ampersand changes this command right here. That single ampersand changed it from a move into an LEA. And people who read x86 code know that an LEA is not the proper operation for this API. So instead of having to scan the entire source code for one single character, if they had looked at it from the binary perspective, it would have popped out at them rather quickly. We found this when we were auditing a lot of the ActiveX controls, and basically I looked at it 3 times and didn't understand why they were doing it until I understood that it was really good for me. And then I stopped questioning that. So there's a lot of implied operations when you're programming too, especially with the C compiler. Is anybody familiar with ISO C99? It's basically this long document that is almost impossible to read through that goes over all the different things that could be implied inside the C language and how to deal with those on a standard basis, basically. It's a really large document, and if you read it, you'll have less friends. So here's a synthetic example of this type of vulnerability. Who knows what it's going to print out, negative or positive? So if you look at the code, it's adding negative 42 to 5. So when you're reading it from a human perspective, you'd say, okay, that's going to be negative 37 right there. However, when you read that huge document that'll rob you of all your friends, you'll see that this operation right here will actually promote the negative number into a really large positive number. So when it adds the two, it'll actually be more in the neighborhood of 4 billion. And basically it'll end up printing out positive, which is completely counterintuitive. But if you were to look at this code in the binary, it would be the difference between a JL instruction or a JA instruction. So again, when you're looking at it from the binary perspective, you can see things like this very clearly. Okay, this is one of my favorite. There haven't been that many bugs that have been found yet that are caused by compiler disturbances. But basically, this is when the compiler decides to be smarter than you. Kind of like Terminator. So right here, this is a code snippet from the Linux kernel. Is anyone familiar with this vulnerability? So this wasn't found by me, but this was a neat vulnerability. Basically, there's a check right here. So anybody who's looking at the source code will say, hey, that's checked, tune cannot be null. However, because it's assigned further up, the GCC compiler says, hey, why are you checking this? You've already said it. Which leads to basically that entire statement being stricken from the binary. So you could look at the source code and say, okay, this is secure code right here. But when you look at it from the binary perspective, that line of code is just completely absent from the binary. And when you get down to here, that results in a lot of bad things without going into too much details. So, okay, I lied. This is actually my favorite type of vulnerability, logic vulnerabilities. So this is a PHP code that I audited. Does anybody know the problem with this one? Basically, username, key, and key are both supplied by the user. And if you pass this check, you're completely authenticated to the system, right? The issue with this is it uses the double ampersands. So basically, this if statement, the code inside it will only be executed if username is supplied and the key is supplied and the authentication fails. So if I don't give it the key or the username, I totally win and basically get to bypass the authentication. So this is a really neat type of bug because it's something where if you're not looking and keeping vigilant for the double ampersand, you will totally miss this bug. So I don't really audit PHP in binary, mostly because I don't know how to. But I just kind of wanted to give sort of an example of this type of bug. So I kind of cheated with this one and threw it in as the red herring. Good pickup, though. So this one's in binary, though. Basically, there was a large for loop surrounding this code. And the large for loop said, I'm going to loop through every valid username you gave me in the file and check to see if the supplied username is one of those valid usernames to log into this machine. And when you're done basically giving all the usernames that are allowed, you need to terminate that with the word no user in order to say no other users besides the ones that have been named so far are allowed to log into this system. Now the neat thing was they decided to see if the username matched something in the file before they decided to try to check to see if it was the no user line. So as long as you were the user no user, you got logged in. It's pretty awesome. This in the binary or in the source. So in the source code, this is kind of hard to spot because you might not be checking line per line. You might be sort of gazing over a function and see, okay, they check for the username and whether or not it's valid. But in the binary, it became quite obvious that no user was the way to go instead of trying to guess a user.